Good morning, everybody. Today we are going to talk more about trigonometric equations here. So we're going to do some techniques that we didn't do last time. Like solve something like this. 2 sine squared theta minus 3 sine theta plus 1 equals 0, where 0 is between when theta is between 0 and 2 pi. So this is, if you look at this is just basically a quadratic equation, okay? This looks just like 2x squared minus 3x plus 1 equals 0. So we're going to solve it the same way we would do that. Okay, we're going to factor this thing. So we're going to turn it, we're going to break it into two pieces. So we're going to have 2 sine theta in one, and we're just going to have a sine theta in the other. And then, so that's my factors of 2 sine squared theta. And then my factors of 1 are just 1 and 1, so that's pretty easy. And I need to make negative 3 in the middle, so I'm going to have a negative 2 sine and another negative sine. So now just go through and check, always double check by foiling this thing and making sure that you go back and get this. So 2 sine theta times sine theta is 2 sine theta squared. That's negative 2 sine minus another sine, that's negative 3 sine theta. And then negative 1 times negative 1 is positive 1. So, okay, we've got this factored correctly. Now, this breaks this into two equations because either this is 0 or this is 0. So, this is going to be 2 sine theta minus 1 equals 0. And over here, we'll get sine theta minus 1 equals 0. And now we just got to solve both of these equations. Okay, so we're going to add 1 to both sides here, and we get 2 sine theta equals 1. And then we would divide by 2. On both sides, and so we get sine theta is 1/2. And then we're going to arc sine that both sides here. So theta is going to be the arc sine of 1/2, which if we consult our trig chart, let's see, we've got arc sine of 1/2 is going to be pi over 6. And there's another one, arc sine of 1/2 is going to be 5 pi over 6. So we got two equations this is going to make here. So theta is going to equal pi over 6 plus 2 pi k. And theta is going to equal 5 pi over 6 plus 2 pi k. All right, now let's solve the other one. So with this one, we're going to add 1 to both sides. And we get sine theta is 1. So we'll go back and consult our chart again because we're going to arc sine that. So where is the sine of theta equal to 1? At pi over 2. And that's it. So, so when we arc sine this, we're going to get theta is going to be pi over 2 plus 2 pi k. All right, now, I only want the solutions between 0 and 2 pi, so that kind of makes this easy here. I don't need the plus 2 pi k because if I add 2 pi to any of these things, I'm going to be outside of the range 0 to 2 pi. So I have three solutions. Theta is going to equal pi over 6, 5 pi over 6, and pi over 2. And we're done. So you're going to treat it just like it's a you're going to treat these just like they're a quadratic formula or a quadratic equation. All right, let's look at this one. So we've got 3 cosine theta plus 3 equals 2 sine squared theta. Okay, so the first thing we should do is well, we can do this a couple ways. But the first thing I'd like to do is I'd like to get this all into the same thing. So we've got sines and we've got cosines. And I would like to get those either into all sines or all cosines. Now I can't really convert this to a sine easily, but I can convert this to a sine easily. So let's change this to 3 cosine theta plus 3 equals 2. Now remember that sine squared theta plus cosine squared theta is 1, right? So if I have a sine squared theta, that's equal to 1 minus cosine squared theta. So I'm going to take this and substitute it in here. And I'm going to make this 1 minus cosine squared theta. Okay, so now it's 3 cosine theta plus 3 equals, and I can distribute my 2 in here. So that's going to be 2 minus 2 cosine squared theta. Now I got it all in cosines. So then I'm going to move all the cosines to one side. I'm going to move these all over here. So I would have 2 cosine squared theta plus 3 cosine theta. Then I'm going to subtract 2 from both sides. So this is going to be plus 1 equals 0. Now it's virtually the same problem that it was on the last one, except it's cosines. So I can go ahead and factor this thing. And if you have a hard time factoring this, just because it looks complicated, just go ahead and change it to this and factor that, and then just go back and put the cosines back in where the x's were. So this is going to be 2 cosine theta and a cosine theta. And I just got 1 and 1 here. So since I've got pluses and pluses, both these are going to be plus. Double check it. So 2 cosine times cosine is 2 cosine squared. 2 cosine times 1 is 2 cosine plus another cosine is 3 cosines, and 1 times 1 is 1. So we're looking good. Now I'm going to break this into 2 equations here. The first one is going to be 2 cosine theta plus 1 equals 0. And the second one is going to be cosine theta plus 1 equals 0. Because remember, when you have a times b equals 0, either a is 0 or b is 0. There's no other numbers that are going to work for that. Okay, so then we just solve this. 2 cosine theta is negative 1. Divide by 2. Cosine theta is negative 1, or negative 1/2. And then I arc sine, or arc cosine, negative 1/2. Consult my chart. So this is the cosine column here. So 2 pi over 3 and 4 pi over 3. So I've got 2 equations now. Theta is going to be 2 pi over 3 plus 2 pi k, and theta is going to be 4 pi over 3 plus 2 pi k. And now we turn our attention to the orange one. So we're going to subtract 1 from both sides, and we're going to arc cosine negative 1. Okay, so consult your chart. Cosine is negative 1 at pi. So theta is going to be pi plus 2 pi k. All right, so then let's see. We want only the answers between 0 and 2 pi, so I'm not going to need the plus 2 pi k any longer. Okay, so theta is going to be 2 pi over 3 pi and 4 pi over 3. If I can, I always try to put them in order from smallest to largest. So there you go. Moving along. Okay, cosine of 2 theta plus 3 equals 5 cosine theta. All right, so it's all in cosines, but the value inside the cosine is not the same, and I really need it to be. So I start thinking, okay, what can I... Well, the first thing I could do is I could move all the cosines onto one side. So let's try that. So this would be cosine 2 theta minus 5 cosine theta plus 3 is 0. Okay, so I got everything on one side. Now I need to deal with this. So remember that cosine 2 theta is cosine squared minus sine squared. Okay, that's from our double angle formulas. So this is going to be changed to cosine squared theta minus sine squared theta minus 5 cosine theta plus 3 is 0. You might say, well, that doesn't really help you much because now I got sines in there. But remember, I can convert this to sines. Okay, so this is going to be cosine squared theta. Remember, sine squared theta is 1 minus cosine squared theta. So I can substitute this for this. And now I've got everything into cosines, and they're all the same angle in the cosine. So let's combine like terms. I'll distribute the minus sign here. So I get cosine squared theta minus 1 plus cosine squared theta minus 5 cosine theta plus 3 equals 0. And combine my like terms, so I got 2 cosine squared thetas by combining those two. Minus 5 cosine theta, and then I can combine those two things, and I get plus 2 equals 0. And now it's time to factor this. Okay, so this is going to be 2 cosine theta and cosine theta. Now I've got factors of 2 or 2 and 1, and I need to arrange them so I can get negative 5 in the middle. So if I put a 2 over here and a 1 here, I get outside is going to be 4 cosine, and the inside is going to be 1 cosine. And I need them both to be negative to make negative 5, and then double check a negative times a negative is a positive. So I factored this correctly. And now I'm going to break the equations apart. So I'm going to have 2 cosine theta minus 1 is 0. And then over here, I'm going to have cosine theta minus 2 is 0. Let's see. And I wanted all the answers just between 0 and 2 pi. So we'll go ahead and solve this one. I'm going to add 1. 2 cosine theta is 1. Divide by 2. Cosine theta is 1/2. And so theta is the arc cosine of 1/2. Okay, so consult my chart. Arc cosine of 1/2. That's going to be pi over 3 and 5 pi over 3. So theta is going to be pi over 3 and 5 pi over 3. Now I didn't write the 2 plus 2 pi k on these because if I add 2 pi to this, I'm going to be outside the range. So there's 2 answers. Now what's going to happen over here? So I'm going to add 2 to both sides, and I get cosine theta is 2. Now, you should realize we got a problem here because sine and cosine are never more than 1. So that tells me that this right here is an extraneous solution. Okay, an extraneous solution is one where you did all the math right and it's a solution, except it doesn't really exist. So yeah, this is not happening. So there's only 2 answers to this, and they're right here, and that's that. So that was a little tougher. We had to use quite a bit of different techniques here. We had to not only use our double angle formula to simplify this, we had to convert sine squared into cosines and do a lot of combining of like terms. Okay, cosine squared plus sine equals 2. So I can't really convert this to cosines, but I can convert this to sines. So let's change this to 1 minus sine squared plus sine. And then we'll move the 2 over here, so we're going to subtract 2. So we've got this. And now let's combine our like terms. Okay, so we'd have a negative sine squared theta plus sine theta. 1 and negative 2 is negative 1. So that's that. Now I don't really like to deal with this when this is negative out here, when the x squared is negative. So I'm going to take all this and add it to the other side. And then I would get sine squared theta minus sine theta plus 1 equals 0. So all I did was take all this and move it over here. Now I don't have to deal with that. Okay, so now I can factor. So I get sine theta and 1, because that's my only choices. And this is also going to be sine theta and 1 over here. And wow, now I got a problem. Because this is not factorable. Okay, I can't put a positive in here because that would make plus 2 sine. And I can't put a negative in here because that would make minus 2 sine. I can't put a plus or a minus in these because that would cancel that out altogether. Okay, so what do I do? Well, this is not factorable. So how do I solve this? Well, I could do the quadratic formula. Now, if it's me, and I'm going to do the quadratic formula, I'm changing this to x squared minus x plus 1 equals 0. And I'm going to do the quadratic formula on this. Okay, so x equals negative b would be positive 1 plus or minus the square root of b squared, so that's negative 1 squared, minus 4 times a, which is 1, times c, which is 1, all over 2a, like that. Okay, so then x is going to be 1 plus or minus the square root. That's 1 minus 4, that's negative 3 over 2. Uh-oh, I got a problem. There's no real solution to this. So that means that there's no real solution to this one. Okay. So no solutions for that one. Okay, sine theta times cosine theta equals -1. Okay, so, excuse me. So we got sine theta times cosine theta is -1. Now, this is a problem because I need to either have sines or cosines. And since it's just sine theta, I can't change that to cosines. And since it's just cosines, I can't change that to sines. So here's what I'm going to do. I do have some equation that relates these to one or the other, and that's this formula right here, that sine of 2 theta is equal to 2 sine theta cosine theta. Okay, so, but I don't have 2 sine theta cosine theta, I just have 1 sine theta cosine theta. So what I'm going to do is I'm going to double both sides of this. That means I'm going to multiply this by 2, I'm going to get -1. That's the same equation, I just multiplied both sides by 2. Okay, now I can use this formula right here and I can change this to sine of 2 theta equals -1. So now I can arc sine both sides. So 2 theta is going to be the arc sine of -1. So let's consult our chart here. And the arc sine of -1 is going to be 3 pi over 2. Okay, so this is going to become 2 theta is going to be 3 pi over 2 plus 2 pi k. Now, this is the first time that we've needed this 2 pi k here, because I've still got this 2 theta over here, and remember that when I have a number in here, it changes the period. So when I solve this thing, the next thing I'm going to do is I'm going to divide both sides by 2. So theta is going to be 3 pi over 2 divided by 2 is going to be 3 pi over 4 plus pi k, because the 2's cancel here. So if I want all the answers between 0 and 2 pi, I'm going to have 3 pi over 4, and then I'm going to add 4 pi over 4 is just pi, so that would be 7 pi over 4. And then if I add another 4 pi over 4, that's 11 pi over 4. That's too big. That's bigger than 2 pi. So this has 2 solutions to it. So there we go. All right, what about this bad boy here? Sine theta plus cosine theta is 1. All right, this one's a little tricky because I've got to relate those sines and cosines so I can convert them. So here's the technique I'm going to use. I'm going to take sine theta plus cosine theta, and I'm going to square that. Let's square both sides. So now this becomes sine squared theta plus, if it's easier for you, go ahead and do this. Sine theta plus cosine theta times sine theta plus cosine theta. And then FOIL it. Okay? But this is, when you FOIL it, this is going to come out to be sine squared theta plus 2 sine cosine plus cosine squared theta equals 1. Okay, now check this out. Sine squared theta plus cosine squared theta, that's just 1. So this is 2 sine theta cosine theta plus 1 equals 1. And if I subtract 1 from both sides, I get 2 sine theta cosine theta is 0. And that looks familiar. That's just, that's sine 2 theta equals 0. So now I can arc sine. So 2 theta is the arc sine of 0. So let's go arc sine 0. That's going to be 0. Arc sine 0 is 0. It's also pi. And it's also 2 pi. Okay? So I get 3 equations out of this. I'm going to get 2 theta is going to be 0 plus 2 pi k. It's going to be 2 theta is going to equal pi plus 2 pi k. And 2 theta is going to equal 2 pi plus 2 pi k. Now the reason I threw the 2 pi on there is because this could have something to do with it since it's on the limit. So, okay. So now I got to solve each one of these. All right, so I divide by 2 on both sides. So theta is 0 plus pi k. And so out of this one, I'm going to get theta is going to be 0. It's going to be pi, and it's going to be 2 pi. All right, now let's check this one. So I divide by 2, and I get theta is going to be pi over 2 plus pi k. So I need to make this 2 pi over 2, so theta is going to be pi over 2, and it's also going to be 3 pi over 2. And if I add another 2 pi over 2, that's 5 pi over 2, that's 2.5 pi's, that's too big. And then lastly, I get this one. So theta is going to be pi plus pi k. All right, well, I already got pi over here, so I don't need it again. And if I add another pi, I'm going to get 2 pi. So these are going to give me the exact same answers as these. They're just repeats. So what are my solutions to this? My solutions are going to be, I run out of colors here. Theta is going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now be really careful because like college professors will trick you up sometimes. You know, they maybe put a less than and not equal to on this one, in which case this would not be an answer then. That's a great thing to trick you up on. So you need to pay attention. So right now this has 5 solutions to this. Okay. So here's your assignment. Got this autograph by Thomas Jefferson earlier today. He was walking down the halls. So anyway, here's your assignment. There's only 18 problems with this. The last couple, you're going to use your graphing calculator, so you're going to want to put those equations in and solve them using that. All right, so good luck, and I will talk to you next time.